Okay, we're gonna start with our chapter 4, build the geodatabase. Now it's in the project. Then early we did exploratory phases. We look at data both in and out of maps and evaluated from various standpoints. We worked a lot with layer properties, but we didn't operate directly on the data. But now we're gonna do it. So, our first task will be populate the Los Angeles River Parkside Project geodatabase with the data sets that we chose. Previously, working with the data will be the introduction to the geographic data processing or geoprocessing, tools that make ArcGIS so powerful that raises the question of whether the project really should have its own database. Couldn't you continue to use the collection of folders and files you have been working so far? Yes, we could, but there are good reasons to consolidate the data and use the Los Angeles River Parkside Project geodatabase that was created automatically when we create the project. We can keep the project data in a single location rather than having it distributed among various workplaces. We can keep the project data separate from datasets that we don't need. We can streamline the project data by eliminating unnecessary features and attributes while maintaining the original source data as a backup. We can impose uniform standards such as common data format and consistent names for datasets. It will be easier to share the project data with others and to reuse it yourself. So that's really cool. And the second task in here will be complete the preparation task in the data requirements table. Besides using geoprocessing tools, we will do spatial queries, table calculations, and other operations. Yay, that's exciting. So for more information, we will see the project database considerations. So that's what we're gonna go through is there are for the simple database, we consider the following issues. So we're going to talk about data format, inputs and outputs, naming conventions in coordinate system, maintenance and documentation, and geodatabase, type of geodatabase. And here I'm going to get into detail. So data formats, the data format. So geodatabase fundamental, we have spatial data formats and geodatabase structure. We would talk about personal file and enterprise geodatabase, components of geodatabase, and about building the geodatabase. So geographic feature data formats are based on representations models of the real world that can be placed in a GIS to produce maps, perform interactive queries, and execute analysis. So CAD, first computer mapping, model format, binary file format with little attribute information. So coverage, native Info 7 format based on georelational data model. Vector data is maintained in index binary files and partitioned form from but linked to attribute tables by a common identifier. Topological relationships are maintained. Shortcomings, features aggregated into collections of points, lines, polygons with generic behavior. The behavior of a line representing a road is the same as behavior of a line representing a string. The interesting thing is that I want to know, sometimes when now I'm using Windows 10, should I go back to use like the original computer? How do I operate on them? I think I could, and then I can learn about history, how computer evolved in this way and not the other way around. So it's an interesting, but it's not worth it. I had a professor ask me a lot about coverage that it's not my generation and I don't know about a lot of coverage that I could just read here and I don't remember it. So that's very interesting. And now all those books never mention coverages at all, only in those slides. And if you go to Esri website, they will talk about coverage. But nowadays, a lot of books, the previous two books about ArcGIS Pro, we never talk about coverages. I don't recall. Okay, so for geographic feature class formats, shapefile introduced with ArcView. So also georelational data model, non-topological vector data format, very prolific format. MuchGIS data in shapefile format. So that's how I know just shapefile. I'm not quite sure about the coverage. Simpler than coverage because they do not store topological associations among different features and feature classes. Limited analysis capabilities due to lack of topology. And geodatabase introducing ArcInfo 8. Object-oriented model can characterize features more naturally by defining objects, types, topological, spatial, and general relationships and interactions. Geodatabase features can be stored in a single database, create custom features in addition to points, lines, polygons, bring physical model closer to logical model. So we put all the data into file geodatabase. The geodatabase is the standard Esri spatial data format, and it has many advantages, large and small. Over the shapefile format, we decided not to use feature classes. Feature datasets are only required to support advanced data structure, topologies, and networks that are not discussed here. See, I told you, even something you just use simple. This book is very easy. Just simple something and build you the understand the project and how you interact with your audience and how to get the results to meet the goal and what is the study question, what we need to find out. So it's more simple in how to put it into use. So here we can do the thematic organizer they use in this way in Esri geodatabase in the source data for this project, but we will not have enough feature classes in the project database to make that worthwhile because this book is just tell you the flow of the work more instead of other books. So we do have a geodatabase. We do have to put it into feature classes and create different features into different things. All right. So inputs and outputs. An analysis project has input and output data. We will store the input or studying data in one geodatabase and the output data in a separate geodatabase. It isn't the only way to do it. We could store both the input and output data in the same geodatabase. The reason we are doing this is in this way is because eventually we might want to run variations on the analysis. This could lead to this would lead to multiple sets of results where each set could consist of several feature classes, keeping track of all that data in one geodatabase will be confusing. So the naming conventions are not right to or wrong in and of themselves ideally. So for the data set and they should be easily easy to remember and easy to apply, but the only real sign that a convention is wrong is that we do not stick to it. Our conventions are as follows here. So to separate world forms with capital letters rather than spaces or underscores, for example, vacant puzzles rather than vacant puzzles or vacant puzzle, this topological convention is called puzzle case or camel case. So how to write it down, the naming convention, and I don't think that we had any chance to learn in a lot of like theory books. So store data type, it's not here yet. Okay, so I'm gonna put the naming here. Let's see, feature class, we talk about feature class, designing, create a new thing, importing. Oh my god, importing things, spatial reference, precising, and it didn't have the naming. Okay, I will add it later here. In this relationship type, you talk about everything. Okay, so here I'm just type it here. Naming convention. So I will add it here. So for the naming convention. But now we can just talk about it. So the naming are not right wrong in the way to do it. So to separate words with capital letters rather than spaces or underscores, we will have vacant puzzles rather than vacant puzzles or vacant puzzles. So this topographic convention is called castle case or camel case. And we will use natural singulars and plurals. For example, LA River, one river, major roads, many roads. So that's very interesting. And to use complete names, not abbreviations. For example, major roads, not major roads. To prefer descriptive names to names that reflect software procedure. For example, exclude park areas is better than parks underscore buffer underscore dissolve and underscore erase. That's very interesting. I'm gonna put naming convention here for the example. We talk about coordinate system in feature classes in a geodatabase don't have to be in the same coordinate system. Feature classes in the same feature datasets do have to be in the same system because ArcGIS Pro projects data on the fly. You don't have to worry about mixing and matching data sets. One reason, however, is to keep all the data in the same coordinate system is that you don't have to think about making sure the data frame is set to the appropriate system. Also, it's considered better practice to make spatial edits to data in its native coordinate system than when it is projected on the fly. We will project all the data in the geodatabase to the state plane California Zone 5 coordinate system. And maintenance and documentation. We don't have to worry about updates, security, quality control, or other issues that apply to keeping a large database up and running. In this case, maintaining the database means keeping it uncluttered. So here in the analysis project, it is common to create datasets that are important link in a chain of processes, but that have no particular value once the end of the chain is reached. If we don't remove this intermediate data from the geodatabase, it accumulates quickly, often making it hard to distinguish critical outputs and results from byproducts. So this is especially true for others who may want to look at or use the data, but it is true for everybody as well. It is in addition to keeping the database trim, we also want to keep it reasonably well documented. Output datasets that we intend to keep should have updated item descriptions to reflect the contents and purposes of the data. And now I'm gonna fill this in, and so that I don't want to come back and talk about it, and it will be a lot of text. So the naming convention, so I'm gonna make it a lot smaller. Now we can also see I'm gonna make it maybe 24. Okay, is it still 24? Yeah, let me dock it. So 24, there, 24. So 24, so to separate words word forms with capital letters rather than spaces or score or underscore. For me, I'm a lazy person. I'm not doing this so well, so I'm not good at this because when I'm naming it, I just name it very easy, and then I still can find it. But sometimes I might lose track. So better you take a note, or better just name it well. Puzzles, vacant puzzles, rather than vacant underscore puzzles, or vacant in space vacant space puzzles. The only thing is this typographic convention is called. You can a lot of professors in class, they like to do underscore, but now I think in ArcGIS Pro, a lot of books now they tend to like this camel form, and which I like it too. Usually I just type everything in lowercase, so which I should learn from it. To use natural singulars and plurals so that we know it's 1 or 2 or 3 or 4, so that we have example that a river is one river, and major roads is many. Major roads are many roads. Okay, so to use complete names, not abbreviations. That example is major roads, not major roads. Well, I could read it, but it's just difficult for people to think, oh, what does this mean? All right. Descriptive names to names that reflect software procedures. And for example, I think I misspelled procedures. Okay, perfect. And for example, excluded park areas is better than parks, and buffer and dissolve. Actually, I like this, so I know what's going on. But think about the name, erase. This is a lot easier to look at it and compare to the other one. Okay, so I think I'm gonna indent this, so that looks a lot better. Yeah. Indent this, so and that all the examples comes here. See? Okay. There. So that's the naming convention. All right. So now the maintenance and the documentation, we talk about it. We don't have to worry about And we're gonna move to types of geodatabase. That's the key thing I want to talk more here. So the types of geodatabase that we have, what is a geodatabase first? Geodatabase, we are here, supported, tabular, we talk about this. What is a geodatabase? A geodatabase of new type of geographic data format for ArcGIS and based on object-oriented model. Users can add behavior properties, rules, and relationships to data implemented as extension to standard relational database technology. Supports topologically integrated feature classes, extends the coverage model with support for complex networks, relationships among feature classes and other object-oriented features, provides platform for development of custom data models using visual tools like case computer-aided software engineering tools and UML, Unified Modeling Language notation. So, a geodatabase can be of three types. So that we're gonna talk about is our catalog, the principal user interface used to define and manage geodatabase. So, personal is just Microsoft Access, and our SDE right now I need to spend some time to learn about Oracle because a lot of places they do focus on Oracle, and SQL Server, Informix, and Database 2 others. So SQL Server I know how to link to ArcMap and our catalog. So right now we do not have a separate because in ArcPro it's not a separate thing. Then you just open ArcGIS Pro. Then our catalog right now it's called catalog window. They used to call it Pro window. Oh no, project window. But now they changed it back to catalog window for now. So the SQL, the book I already showed you how to link there. The first one, we do have like three types. So here it only lists two. So a file geodatabase that with extension GDB is stored as a collection of system files in a folder. It has no total size limit. Each dataset within the geodatabase has a default size limit of 1 terabytes, which can be increased to 256 terabytes. Multiple users can currently add different datasets within the geodatabase. And the personal single user geodatabase with extension is MDB. It's a Microsoft Access database. So it has a total size of 2 gigabytes. Only one user at a time can add the database file, and a personal geodatabase serve the same purpose. The personal geodatabase is just an older version of the technology. So here I'm already mentioned implemented as a Microsoft Access database MDB file by using the MS Jet engine, which is installed with a i8. Microsoft Access is not needed. It can be placed on local or network drives, generally used for personal or small group use, can handle small to moderately sized database. Personal geodatabases can yield decent performance for a database of 250,000 objects or less. Maximum size is 2 gigabytes. Full functionality of geodatabase served through SDE except versioning. Versioning allows many editors to work currently and include framework to resolve added conflicts. If a personal geodatabase is deleted, it's gone. So if I would go into my geodatabase and then right click on it, and then it's just gone. Next is the ArcSDE Enterprise geodatabase. It is stored in a relational database system such as Oracle, Microsoft SQL Server, PostgreSQL, or IMB DBS. SDE stands for Spatial Data Engine. Its size limits are determined by the database system in which it resigns. Enterprise geodatabases support concurrent editing on individual datasets and provide database administration tools. So the personal geodatabases are accessible with ArcMap but not ArcGIS Pro. Personal geodatabases are accessible with ArcMap but not ArcGIS Pro. Cool. So personal geodatabases are accessible with ArcMap but not ArcGIS Pro. So that's why my licensing is advanced. So that's really cool. But it's gonna expire. But you have to spend money to buy the licensing. So exercise 4A, we will start project shapefile, but we are not going to start until we finish talking about the geodatabase in detail. So the geodatabase elements, we have objects, classes, feature classes, and feature datasets, spatial references, domain, subtypes, relationships and relationship classes, geometric networks, label, and annotation. So we did a lot for domain, and you create different types, and then you can do is for ArcGIS collector. So that was within the attribute table, okay, the feature class. So objects and object classes. Geodatabases organize geographic data into a hierarchy of data objects. So objects are instances of an object class that have properties and behavior. So objects can be related to other objects via relationships. Objects have a unique system identifiers, object ID. Object classes are tables in a geodatabase storing non-spatial data, for example, parcel owners. Objects in an object class have the same properties stored in the table as attributes, behavior implemented as a component. Object classes, so we have tables, features, and feature classes. Features are objects with required shape points, multipoints, lines, and polygons that represent a real-world object in a layer on a map. So features classes are collections of features with same types of feature, geometry, and attributes. A feature class is also an object class with stores spatial objects features, for example, puzzles. All the features in a feature class are in the same spatial reference, and feature classes with stored topological features must be contained with a feature dataset to ensure a common spatial reference. So the feature class table, you have objects, shape type, and you will have to look when you right click on and see the attribute table. Feature class datasets. So contains 4 feature classes share spatial reference, analogous to a coverage less restrictive, may also contain relationship classes, geometric network, and annotation. Building a geodatabase. So building a geodatabase, designing the geodatabase, think before you create. Creating a new geodatabase name and location only. Define the geodatabase structure, schema, and data. So entering spatial data, loading, or automation, define additional properties, validation, relationships, networks. So we create a new and defining the database structure, entering spatial data, define additional properties, and importing export data, importing data into the ArcGIS, the geodatabase, not ArcGIS. Designing a geodatabase. So conceptual plan. Current and future needs, data contents coordinate system, data validation and modification rules, relationships among objects, custom objects. So Microsoft Visum Enterprise version. So logical design can use case tools, what needs to store, not how to store. UML use case, Microsoft Version Enterprise Edition. Creating a new geodatabase. So in our catalog, we can just right click on it, a new geodatabase. create a geodatabase using ArcGISProCatalog, create a new rename default names, and defining geodatabase structure. So create from scratch manually. Use tools in ArcGISProCatalog to create schema. Importing existing database schema can convert by importing schema from existing datasets. Use case tools and UML to automate database creation. Can use case tools to create new custom objects and or generate a geodatabase schema for UML, case computer-aided software engineering, and unified modeling language. So create schema from scratch manually. That define structure using ArcGISProCatalog, feature datasets, feature classes, tables, relationship classes, and what to define is database name, file name, and properties, spatial reference, table relationship parameters. So that you input existing database schema. So you import data or database schema shape files, coverage, feature, class, info, and database tables. So you just right click on it and import. And you can import. And now let's double check. I don't think that in our, let's go to database. Okay, I have a database, so I'm gonna import. So now feature class, everything. It's a huge change compared to the old version here. Because we don't have coverage table to geodatabase. So now the option, let me show you again. The option we import, we just have feature class, feature classes, table, and tables. So it's a lot different now, okay? So import data or geodatabase, shapefile coverages, feature classes. Right now, we didn't see any shapefile coverage. It's just feature class or feature classes, table or tables. So it's a lot easier for now, okay? So options while importing: rename objects, rename, exclude attribute columns, modify spatial reference, insert feature class into feature classes, feature dataset. So use case tool to UML. So this thing is really old, okay? Because it always talk about ArcInfo, and I think this professor, yeah, he was old, and GISC. So use case tools and UML to define dataset structure, physical design using UML, feature class, relationship class, subtype and or domain schema, design large dataset with visualization and documentation of data relationship and attributes. So added Esri object model diagram, create customized objects inherited from Esri's objects, Arc objects, export structure to Microsoft repository, then to ArcGISProCatalog. So Visual Basic, and now they can do Visual Basic for sure. For VB with our GIS application and map objects. Substitute computer techniques, GIS application software development, Arc objects plus UML. And now we have a Python and JavaScript, and it's all already implemented here in ArcGISPro. Yeah, you could do JavaScript, I think. Entering spatial data automation options, analog data digitizing or scanning, ArcInfo formats, importing and loading, other digital data conversion, data mapping, vector geometry types, so XY points, multi-points, lines, polygons. So if you say points, multi-points, lines, and polygon, what are the difference between point and points? So line and lines, polygon and multi-polygons. So we can do multi-polygons as well. So Z optional positioning, Z elevation. Yeah. Optional linear measurement and the milepost field mapping, spatial reference. And next is importing versus loading. Importing creates new features within a new feature class or geodatabase table. The feature classes or table cannot exist before importing. Database schema is imported at the same time. Loading appends features into an existing feature class. Existing feature class have the same schema with the data sources. Simple data loader, ArcGISProCatalog, object loader, wizard, ArcMap. So that's interesting to know, simple data loader or catalog. But now we do not really separate these terms. I think the professors usually told us, well, you have to study the science behind it. It won't change in 30 years, but I think the technology changes. The science, the theory, you put it here. You have to change this. You have to keep updated with the technology. So defining an additional database properties, leveraging geodatabase advantages, add validation rules, subtype, and domain, define relationships between tables, create topological structure, geometric network, and create annotation. So spatial reference coordinate system, spatial domain precision cautious. All feature classes with a feature class datasets share the same spatial reference. Once created, the spatial domain for feature datasets class cannot be changed, and data outside extent of dataset needs to be created in a new feature datasets or standalone feature class. Coordinate system, we spent a lot of time to talk about it, and now that's why we're doing ArcGIS Pro. If you don't study Pro, will you go back and use the old version to deal with the coverage? We are not going back to study those software. Of course, we are using. Will you go back to use old cell phone, or you're gonna buy the newer version of the cell phone? Of course, that's what we're gonna do. We will not go back to of course we can understand it, but for the thing, that's why I'm doing ArcGIS Pro, because we are going to use it. Will you use ArcGIS 8.3? Of course not. Okay, so that's the point. So coordinate system, we will do projection system and parameters. Now, the geographic UTM and state plane, we already talked about what is UTM, what is state plane. State plane, we didn't spend a lot of time. But we did spend a lot of time to talk about datum, central meridian, standard, parallel, false, northing, and easting. So the defined coordinate system for feature class datasets, we select predefined coordinate system, import from existing geodatabase, create a new coordinate system, modify current coordinate system, save for future use. That's what we're gonna do in ArcGIS Pro, and it will be totally different from here. Okay. Interface, but the theory and how the data structure and the basic button is still there. It's just the interface and how you do it is a little different. So spatial domain, the allowable coordinate range for the geographic coordinates. So x and y domain, so we have a minimum x and maximum x, minimum y and maximum y. The z domain, minimum, maximum, and m domain, minimum and maximum. So the precision, the number of system units per 1 unit of measurement of distance. Precision determines the resolution of a map geodatabase. So for example, map unit is meter, precision 1 system unit is 1 meter resolution. Precision of 1,000 system units is 1 meter. So 1 system units 0.001 meter is 1 millimeter resolution. Map unit feet, precision of 12, resolution. So 12 system units 1 foot, one system unit is 1/12 foot, and which is 1 inch resolution. That's interesting to know. Okay, and determine precision based on map resolution. The formula is resolution is map unit divided into precision. Precision is map unit divided by resolution. So precision and resolution. It's interesting that they inversely for the denominator. Okay. So determine precision of a new geodatabase. Digitizing table resolution is 0.002 inches and map scale as 1 versus 10,000. Maps units is meter. Geodatabase resolution. So 0.002 inches times 10,000 equals 20 inches. 20 inches equals 20 divided by 30, 39.37 meters, and which is 0.508 meter. 0.5 meter precision. 1 meter divided by 0.5 meter, which is equal to. Geodatabase storage and precision coverage, shapefile storage, single floating point precision, 6 to 7 digits, double floating point precision, 13 to 14 digits. Geodatabase storage as integer 4-byte integer stores 2.14 billion system units, max is 2,147,483,446. Coordinates are multiplied by precision when stored, divided by precision when used. So database precision units, so when we have to calculate them, we will go into detail, but I don't think we will go into that detail to talk about those map units, check geodata's precision with range. It could be nice, so range in map units, range MU. So larger of width or height, width. So you have a maximum x minus minimum x. Height is maximum y minus minimum y. For example, then you just use the maximum minus the minimum. Then you get the range. Recenter coordinates using shift. Problem of desired precision. Data is outside extend solution that shift the center of geodatabase space to the center of the data. Shift the differences between the center of the data and geodatabase central MU. Formula center of geodatabase space in map units. So that much number you divided by precision center of the data. Data minimum x plus data maximum x divided by 2, and data minimum y plus data maximum y divided by 2. Shift, so that we have this. Okay. And geodatabase storage and shift. So this is kind of difficult to understand. So the geodatabase will subtract shift, then multiply coordinate by precision when stored, divide coordinate by precision when add, shift when used. The storage and shift. So it didn't talk about here. It didn't talk about why we need the shift. So subtype and attribute domain. So let's go back up shift. So resolution using shift, recenter. So that's why it's shift. That we recenter. Okay, I understand we have to recenter when you have different data. Okay. And subtype and attribute domain. Subtype, attribute domain, range domain, coded value domain, associated domain with subtype. Attributes validate rules, split and merge domain policies. So what subtypes and attribute domains? So data integrity. Prevent illegal attribute assignment for features, tables with out-of-range data values for certain critical field, provide predefined codes as the only valid values. Data efficiency, associate different subset of a feature class with different default values. Attribute validation rules allow efficient choice from a set of valid value description rather than manually input the value itself. Those subtypes, okay, subtype feature class subclasses that allow you to further distinguish the object without creating new feature classes, logical groups of a subset of records within a feature class based on single column's value. Same subtypes as has similar attribute values and behaviors. Create subtypes, can choose default subtype, and require integer values long, short, user adds descriptions, can have different default values and domains for each field to improve data efficiency. Create subtypes. Define subtypes using our catalog for feature class or table properties. Number 1, we select columns to create subtypes and enter subtype code and description, and then enter default values and domain for each subtype, set default subtype. So we did this. Feature class properties and subtype, and I think for ArcGIS Pro it's changing a lot more. that we will have to compare when we create the subtype. We go back to, it will be the attribute table that we can just set it there. So instead of in GeoDatabase, I don't recall that we do that a lot. So creating the subtype we did for the ArcGIS collector, remember? So display and add subtypes in ArcMap. So displaying subtypes can have a unique classification. Subtypes descriptions are listed in TOC. Symbols can be modified as desired. Adding new features. Use the editor target list to add feature with chosen subtype, and editing existing features. Records can apply subtypes after data entry. Subtypes fields show description, not nodes. Changing the subtype updates the default values for other fields. So the domain. So for domain, I really like the domain because we could do is that we can create the recall from the ArcGIS collector. We create a domain and we put a subtype, and we chose the type there, and we can select things. So if the people go out in a field that we want to collect different data, that we can just use the drop down menu. You create, for example, you have land use or trees types, or after the hurricane. That's very useful here. So we're going to spend some time to talk about the creating domain thing. Define a set of legal values for a field's attributes. So the range, specify a valid range of values for a numerical attributes. A water pipe must be between 1 and 100 inches wide. So you can put those numbers in between there. Encoded value specifies a valid set of values for an attribute. Can apply to any type of attributes. Puzzles can only have RES or VAC land use values. So validation method, pull down list of descriptions, coded values prevents error. Validation during added section prevents range error. So GeoDatabase property can apply to entire field or individual field subtypes. Multiple objects in the same database may use the same domain. Cannot edit domain referenced by another subtypes. So creating range domains. So this is very useful. That I never done this before. I don't think in this book they will go into that detail to show you how to do it in ArcGIS Pro. But at some point I might want to spend some time to explore this feature. Creating range domains. Click on existing or blank domain. Enter the name and description for the domain. Enter the domain properties. We have a field type, domain type, range, minimum value, maximum value, split policy, merge policy. So creating coded value domains. That click on existing or blank domain. Enter the name and a description for the domain. Enter the domain properties. Field type, domain type, coded values, split policy, merge policy. Enter the coded value, code description. Associating domains to entire fields. So provide validation for records within a specified field. Domain must be defined as same field type. Diameter L is floating, only float domain a pair. And associating domains to subtype. Provide validation for records within subtype. Domain must be defined as same field type. Subtype field grouped into 4 codes. Each code has its own domain for other attributes. So editing records that have a coded value domains. So ArcMap only shows valid domain description. View codes in table by changing the appearance of the table. Editing records that have a range domains. So this will be, we barely use this. Perform edits in ArcMap. Validate section. Selection verifies fields with a range domain. Invalid features remain selected. So split domain policies. So this is interesting, that split policies on added features attributes. Split policy. So if we draw a line between here, 1, 2, you see right here, and we duplicate the field in zoning, we will have to rename it default value, and then geometry ratio, we cut it and spread the ratio. And the other way, you split and you can merge policies on edit, feature, attributes. So you have to have a big thing. So like Greenwood, Lakeview, it's a small area and it's all belong to California, and yield, you add them together, 24,000 plus 45,000, you get 69,000. And harvested, so you add them up and you divide it by 2. So I think it was 82 divided by 2, 81 divided by 2, weighted average. So it's not really kind of average is average. So and table association and a table join. So table association, that we do table join, but in GeoDatabase, that, let's see, so it has the relationship there that you can play around with the relationship, so that allows you to join and relates. So table association and a table join. So table association, attributes about a feature can be stored, feature class table, feature class, separate table, object class, associate tables with common column key values, primary key, common field on original table, foreign keys, common field on destination table. Table join, merge two tables together into one table logically or physically in ArcMap. Relationship and relationship class. Relationship, persistent and a dynamic association between objects in the GeoDatabase. Change to original table can be seen when the destination accesses the relationship. The relationship exists unless deleted. No merging of two tables. Common field with same data type between non-spatial objects. Row in tables between spatial objects. Features in feature classes between spatial and non-spatial objects. No relationship based on BLOB fields. No relationship based on location. Relationship class. A GeoDatabase relationship is stored in relationship classes. It is saved as a record row as a relationship table. So GeoDatabase relationship characteristics of relationship. Persisted relationship in the GeoDatabase can enforce dependent behavior, can edit, query, and symbolize. A cross relationship can only relate tables within the same GeoDatabase. Do not support access to stacked relationship. So if A to B and B to C, then A cannot access C unless A to C. So if you do not have the B as a bridge, you cannot cross the river. Creating relationship class. Relationship properties, relationship name, origin, and destination tables, relationship types, simple or composite, from to from labels. So messaging, the direction, cardinality, one-to-one, one-to-many, many to none. I don't know, and I forgot, sorry. Foreign key and primary key. So the many to many. Oh, many to many. I remember many to many, but I don't remember the N. Why it's not MM. So table relationship cardinality. Cardinality, I have to go over to review the cardinality. So cardinality, we define how many objects are related to B. Object influence relationship properties and uses. So one-to-one, one-to-many, many-to-many. So the relationship type, so like one-to-one, so it's just like you have your own room, go back to your room, okay? And then one has many owners, so everybody coming to one room have a meeting. So many parcel have a many owners, so I can have a 2 land, and this you can overlap. So I really like that graph, so easy to remember and easy to understand. So relationship type. So simple pair-to-pair relationship. So the pair-to-pair relationship that are between two or more objects that exist independently for each other. Delete origin objects, related objects in destination. Table continues to exist. FK value is deleted. Can have a one-to-one, one-to-many, or many to. Here is one-to-many, not one-to-many. Or many-to-many cardinality. Composite relationship. The lifetime of many controls the lifetime of its relationship objects. Destination objects cannot exist without origin objects. So can only have a one-to-one and one-to-many cardinality. Okay, let's look at the keys, paths, labels, and messaging notification. So from origin to destination based on common field, primary key (PK) on original puzzles, foreign key on destination owners, path labels. Forward from to navigate the relationship from the origin table to the destination table. For example, is on by backward from to or from to navigate the relationship from the destination table to the origin table. For example, owns. Messaging notification. Direction to propagate standard message between related objects used to trigger behavior. For example, cascade move, custom origin to destination, destination to origin, both and none. And the relationship, rules, and validation. So properties set after creating the relationship class. So we can control which object subtypes from origin class can be related to which object subtypes in destination class. Also, the valid cardinality range for all permissible subtype pairs. Cardinality 1-to-1, 1-to-many. Many to one. So like many people go to one room, and then many to many. So that image really helped me to understand 1-to-1. So everybody go back to its own room, and everybody go to a meeting room. You attend a meeting there. So like you could have one person you can have a tool in, and the other person like they can own the same land. So many to many. Okay. Thus determine or control the actual quantity and types of related records. Valid selection. Track for attribute violation after validation. All invalid records remain selected. So open related table in ArcMap. Add origin table, destination table, or both. Table appears in table of contents source tab. Open table. Use option related table. Query related table. Query records from first table using option selection attribute. Click options relationship and path label name to refresh related table, and select records highlighted in related table regardless of messaging. So symbolizing and labeling with related features, property fields, tab, related fields. We might not work everything on here. Displaying and adding related records. So if we have the puzzles, that classification-based related fields appear in the table of contents, fields related table in attribute dialog. Same. So the naming convention, we already talked about it. I'm gonna see you soon. And next time we will know more slides, and we will work on ArcGIS Pro, starting from the project a shapefile, and then we will move to project shapefile. That's projection we talk about here, and then we will do copy a feature class. How would you copy a feature class? And then prepare the city and county data, and we have a lot to do. And also we will prepare the river data. After we prepare the river data, we will prepare the park data, and we will do geoprocessing tool here. Yeah, geoprocessing tools will be very neat in here. And then, yeah, we talk about the merge, and we will look at the fields. We will observe those fields and look at the output, input, and field data types. Yep, we will go over all the field data types and in detail. And then we will prepare for block group data. It's a lot of data to prepare, and we will calculate population density. It's a lot of calculation and stuff, and we will use some tool and prepare the puzzle data. And table joins and relates, that's very nice. And we talk about the cardinalities already, and we will do table joins here, so we will understand a lot better. And that's it. Okay.